Hello everyone, this is Anishu, and in the previous video we learned about basic dependency injection and how to implement basic object relational mapping techniques. In this video we will be diving into advanced ORM techniques by implementing the repository pattern using Entity Framework Core. In contrast to the previous video where we used direct database access and micro object relational mapping, in this video, we will be implementing a full object relational mapping using the Entity Framework Core. For this application, apart from the previously installed libraries, we will need to install the npg Entity Framework Core PostgreSQL library and the Microsoft Entity Framework Core.design library. We will also need the .NET EF command line tools, and we will be installing them using the .NET tool install command. Our approach for this application will be the database first approach. That is, we will be first creating the database tables, and from that we will generate our models and the context. For generating the models and the context, we will use the scaffold command. After running the scaffold command, we will get our models that is directly generated by the database and the database context, which in our case is the robot context class. Now coming to the models that are generated by the scaffold command. For this application, we will not be using the models that we have initially generated ourselves. We will be using the models generated by the scaffold command. We can see that the scaffold command only generates the properties. So we will update the model files and add the constructors that are required in our project. We are adding the constructors because we want to compare the other implementations with the EF implementation, else there is no need to add the constructors. As you can see, the models generated by the scaffold commands are partial classes. This is used to tell the compiler that there might be an extra implementation for this class somewhere else. Coming to the database context class generated by the Entity Framework Core's scaffold command, the name of our class is robot context. It facilitates the interaction between the application and the database. The key features of this include the defining of entity sets for the database table, that is the DB set properties, configuring database connection strings, that is on configuring method, and defining entity mappings, that is the on model creating method, and handling the database interactions, the save changes methods. Additionally, I have also incorporated the feature of data login to do debugging and testing of our program. Overall, this robot context class acts as the bridge between the application and the underlying database, providing essential functionality for data access and manipulation throughout the program. In the program CS, we will be registering the robot context class with the dependency injection container using the EF Core's addDBContext method. This will allow our application to access the database through the robot context class and perform operations such as querying, inserting, updating, and deleting the data using the EF's ORM capabilities. The interfaces that we will be needing in our robot command EF and map EF are the iRobot command data access and imap data access, which are same as the previous implementation. Now coming to the EF files that we have created. In the robot command EF class, we have implemented the iRobot data access interface using EF core. We will inject an instance of the robot context into the constructor, allowing us to interact with the database. Now coming to the getRobot commands method. This method retrieves all robot commands from the database by accessing the robot commands DBset property from the robot context and converting it to a list. Next, the updateRobot command. When updating a robot command, we first find the existing command in the context using its ID. Then we modify its properties based on the update command provided as an argument and save these changes to the database using context.savechanges. Next, the insertRobot command method, which is used for inserting a new command. We will add the new command to the robot commands DB set within the context and save these changes to the database using context.savechanges. Finally, the deleteRobot command method. To delete a command, we will first find it in the context based on its ID. If the command exists, we remove it from the robot commands DB set and save these changes to the database using context.savechanges. Overall, by leveraging the EF core, we will abstract away the complexities of the database interactions, making our code cleaner, more maintainable, and less error prone. Again, similar to the robot commands EF, in the map EF, we will inject an instance of the robot context into the class via constructor injection, facilitating interaction with the database. Now the get all maps retrieves all maps from the database by accessing the maps dvset property of robot context and converting that into a list. The update map updates a map by finding the existing map in the context based on its ID, then modifying its properties using data from the update map and save these changes to the database. Now the insert map inserts a new map to the database by adding it to the map dbset within the context and saving these changes to the database. Similarly, the delete map deletes a map by finding it in the context based on its ID. If the map exists, we remove it from the maps dbset and save these changes to the database. With that, the explanation for the robot commands EF and maps EF is complete. Finally, in the program CS, we will configure the dependency injection container to map the interfaces iRobot command data access and IMAP data access to their corresponding concrete implementation, that is robot command EF and the map EF. This will enable the application to use this implementation whenever an instance of the corresponding interface is requested throughout the program. Before running the application and testing, let me tell you that the controllers file will remain the same as the previous implementation in this one, as well as we have been implementing the similar iRobot command data access and IMAP data access in all the implementations of dependency injection and ORM. Finally, coming to testing, we will run the application and execute the corresponding endpoints in the Postman. We can see that all the endpoints, including the get, post, put and delete endpoints, work just fine and as intended, thereby verifying that our implementation is correct. I hope you enjoyed the video. Stay tuned for the next one. Thank you.